Hello friends, in this video we will solve some problems based on Laplace transformation. So you will actually get an idea when to use Laplace transformation for solving the problems, because most of the times in gate problems they never specify the type of approach that you need to apply. Let's see. Let's start with question number 1. It is given like this. The question is, determine I of t for t greater than or equal to 0. So we'll see how to deal with this. Now the scenario is, this moreover looks like a transient problem. Of course it is a transient problem, but if you remember, I told you very clearly, when you have I of t for t greater than or equal to 0, you had standard equation as ISS plus k into e to the power minus t by tau. But that formula has got some limitation. The limitation is you can apply it only for RL circuit or RC circuit. You cannot apply it for RLC circuit because RLC is a second order circuit. In that case, you have to always apply Laplace approach only. Please remember, whenever you have to get I of t for t greater than 0 or V of t for t greater than 0, and if the circuit is RL or RC circuit, a traditional time domain approach is valid. That is, V of t is equal to VSS plus k into e to the power minus t by tau for voltage, and ISS plus k into e to the power minus t by tau for current is valid. But when it comes to RLC circuit, those methods are not available or not applicable. So here we are going to solve the same problem, same kind of problem in fact that we have solved in transient analysis, but by Laplace approach. We'll see how to go about it. Tell me, for t less than 0, what do you think? Switch was open, and if the switch was open, it means clearly that your inductor as well as capacitor remains uncharged. So whole motive is just to get initial conditions for inductor, which is 0 ampere in this case, as well as for capacitor it is 0 volt. Am I right? We can now directly go for t greater than 0. For t greater than 0, we transform the circuit in Laplace. So see your circuit. Your circuit have every element like 50 volt, I of t, 2 ohms, 1 Henry, 1 by 2 farad. Every element here gets converted into Laplace domain. So for example, I am talking about 50 volt, which becomes 50 by s after Laplace transformation, because you know the fact that constant have got Laplace transform as k by s. Whereas your 2 ohms remains 2 only, because you know the fact that R remains R even after Laplace transformation. Whereas when it comes to inductor L, if you remember, it gives you this kind of circuit, Ls minus plus L times I naught. But since I naught value equal to 0, therefore the circuit will become only Ls. And you know the fact that L is having value as 1 Henry here. So this model simply becomes S. Is that right? This is for inductor. For capacitor, it is simply 1 upon Cs plus minus V naught by S. Here the value of C is 1 by 2. See, C is having value as 1 by 2 farad, and V naught is simply 0 volt. Let us substitute over here. 1 upon Cs, because C is equal to 1 by 2, will become 2 by S. Of course unit is ohms, and since V naught is equal to 0, it will be simply short circuit. So now we will replace inductors and capacitor with their equivalent models, and resistor of course remains same. So now circuit becomes like this: 50 by S. Resistor is simply 2 ohms, inductor it's simply S, and capacitor has become 2 by S. And this becomes I of S. So now I of S, you understand it, this is 2 ohms, this is S, nothing but S ohms, and 2 by S is also having unit as ohms. All of them are ohms, it means equivalent impedance can be calculated by simply adding them. So the total voltage divided by total impedance gives you current. So by Ohm's law, I can write I of S is equal to voltage, which is 50 by S, whole divided by total addition of all the impedances, which is 2 plus S plus 2 by S. So now I of S becomes 50 by S whole divided by S square plus 2S plus 2 by S. This S and S will get cancelled. So I of S becomes simply 50 divided by S square plus 2S plus 2. I can rewrite I of S like this. I'll keep denominator same, which is 50 divided by S square plus 2S. I can write 2 as 1 plus 1. I'm doing this just as to make it perfect square as a denominator. So I of S I can write 50 upon C. Observe this. Can I write S square plus 2S plus 1 as S plus 1 the whole square? Similarly, I can write 1, remaining 1 as 1 square. I have to always relate this with this kind of formula, that is B upon S plus A whole square plus B square is e raised to minus 80 times sin bt. So now comparing, you'll come to know that A is equal to 1 and B is equal to 1. So now by having inverse Laplace of this, it becomes simple I of t, which is equal to, look, at 50 it is constant, I'll just take it out, and now it becomes simply e to the power minus t sin of t u of t, and of course it is ampere. So this is the value of I of t. So either you write dot u of t, or if you remove u of t, then you can write I of t, it's simply 50 into e to the power minus t sin t. Now here you specify t greater than or equal to 0. If you write u of t, then it bound to become valid for t greater than 0 only. If you don't specify u of t, you have to write it mathematically t greater than or equal to 0. This is how we deal with series RLC circuit using Laplace model or Laplace approach. Let's start with the next sum. The question is to determine I of t. How we are going to solve this? Determine I of t when the spatial signal is given del of t. Let me tell you, time domain approach is not applicable here because time domain cannot handle such signals like del of t. You know, in fact, del of t is a signal which is present only at t equal to 0. So how we can really solve it? By using time approach. So we go for frequency approach here, or frequency domain analysis here. So transforming this into frequency domain, I can say that del of t simply becomes 1 volt, R remains same, which is 10 ohms, and since initial conditions are 0, L can be replaced with Ls, which is nothing but 5S, and then we have this I of S as current. Now you may get wondered, how come do we come to know that inductor has got no initial voltage or initial current? Del of t is nothing but signal like this, which is only present at t equal to 0, meaning that for t less than 0 or t greater than 0, del of t is always 0. So before 0, there was absolutely no voltage applied, and that's the reason why I have taken initial current for inductor equal to 0. So I can replace L with Ls. In this case it is 5 Henry, so I have replaced with 5S. So see to it what I of S you will get. It is simple, voltage divided by total impedance. We know the fact that even this has got unit as ohms. So I of S will become 1 upon 5S plus 10. So I of S is simply 1 upon, if I take 5 common, it becomes S plus 2. So I of t can be written as 1 upon 5, and 1 upon S plus 2 inverse Laplace is e to the power minus 2t times u of t, and that's ampere. Again we have got I of t current. So please remember, when it comes to RLC circuit and if you have to find I of t or V of t, then you have to go for Laplace transformation only. Also, even if the circuit is RL or RC circuit, sometimes you cannot go for time domain approach when the signals are special signals like del of t, like r of t, like r of t minus 2 or del of t minus 4, or the signal can be a trigonometry signal like sin bt, cos bt, etc. Then you cannot go for time domain approach. You have to go for Laplace domain approach only. Let's move to the next problem now. Next problem is from GATE 2016. In this problem, they have given some circuit like this. They have provided that L value is 2 millihenry. In this problem, L value is given as 2 millihenry, and at the same time, you have to calculate I naught here. I naught means initial current through the inductor. So how we can proceed this? You know the fact that this is actually the Laplace model for inductor. So if you really compare with standard Laplace model for inductor, it is like this. Ls, and then in the series we have minus plus L times I naught. Am I right? So now if you compare this, the value of L you can compare with this. So as you can see, L is simply 0.002 Henry, or you can write 2 millihenry. But again, it was given in the problem itself, so there is absolutely no problem. It is valid. Simply 1 millivolt can be compared with L times I naught. So I can say L times I naught is 1 millivolt, which is 1 into 10 to the power minus 3. In this case, I naught is simply 1 into 10 to the power minus 3 divided by L. And what is L value? L value is 2 millihenry, which is 2 into 10 to the power minus 3. So 10 to the power minus 3, 10 to the power minus 3 can be cancelled it out, and I naught 2, it's simply 1 by 2 ampere, or you can say 0.5 ampere. So the value of I naught they have asked. So this is how we can deal with this. So if you know the basics, you can see most of the problems you can crack it easily. Let's move to the next problem. Next problem is from GATE 2004. What they have provided is RLC circuit. R is having value as 1 ohms. Inductor has got value as 1 Henry, and the capacitor value is 1 farad. Very simple values are given, through which they have applied voltage V of t. Along with this, some information given about initial conditions like IL of 0 minus they have given as 1 ampere. Voltage across capacitor at 0 minus is given as minus 1 volt, and the value of V of t is simply U of t they have provided. And in turn, they are asking you the value of I of t, and for this they are asking you the Laplace transformation of I of t, and they have provided 4 options. Option A is s upon s square plus s plus 1. Option B is s plus 2 upon s square plus s plus 1. Option C is s minus 2 upon s raised to 4 plus s plus 1. And option D is s minus 2 upon s square plus s plus 1. Here it is clear indication that you have to use Laplace transformation. Otherwise, if they would have not mentioned, we will still would have gone for Laplace transformation only, since it is RLC circuit. We know the fact that when it is RLC circuit, we cannot go for time domain approach. So let's see how to handle this. So here, your V of t is U of t, which will give Laplace as 1 by s. Secondly, resistor remains same even after Laplace transformation, whereas inductor L, you know the fact that it becomes Ls and then minus plus L I naught. In this case, just pay attention, I naught is called as initial current through the capacitor. As you can see, they have given IL 0 minus, means it is I naught only, that is initial current through the inductor. Whereas Vc0 minus means initial voltage on the capacitor, which is V naught here. So now it will become like this. The value of L is 1 Henry, so it becomes S. Whereas minus plus L times I naught. What is the value of L? It is 1. And what is the value of I naught? It is also 1. So it simply become 1 volt, right? Whereas capacitor C is replaced with 1 upon Cs, and then in series it is plus minus V naught by S. In that case, your capacitor 1 upon Cs, the value of C is again 1, so it is 1 by S. Then the voltage comes, which is V naught by S. What is the value of V naught? You can see the value of V naught is minus 1. If the magnitude is negative, we can make it positive by inversing the polarity. Try to understand it. The polarity over here is plus minus, but the magnitude is positive. If the magnitude becomes negative, then we can reverse the polarity. So what is the magnitude? Magnitude is minus 1. So V naught by S will be replaced with minus 1 by S with polarity plus minus. Rather, with plus minus, I'll make it minus plus, and V naught by S I can write it as 1 by S volt. Am I right? So now what we can do is we can draw a complete circuit, and we will get V of S as, since V of t they have given as U of t, we can get V of S as 1 by S, and then we can draw the complete circuit now. So as you can see in the circuit, we have to find I of S. We can have simple Ohm's law, total voltage divided by total impedance in the circuit. So I of S is simply total voltage. Now voltage can be added. 1 by S, 1 volt plus 1 by S can be added. So it is like this: 1 by S plus 1 by S whole divided by total impedance, which is S ohms, 1 ohms along with 1 by S ohms. So it is 1 plus S plus 1 by S. So I of S becomes now 2 plus S whole divided by S, and then it is S square plus S plus 1 whole divided by S. So this S will get cancelled, and you will get I of S as S plus 2 upon S square plus S plus 1, and this becomes your I of S, that is Laplace of I of t for t greater than or equal to 0. So let's go to the options. As you can see, option number B is the correct option. I'm sure you have understood all these problems. Thank you.